Welcome to lesson 1. In this lesson, I'll discuss about microcontrollers. So before going to tell you about microcontrollers, you should know why we need a microcontroller. So to explain this, I have a very good example. Suppose I have a project where I need a MOSFET for switching. I need one oscillator to generate clock pulses. I need a timer to generate time delay. Then I need a counter. Counter will count pulses. I need one ADC which will convert incoming analog signals into digital data. I need a PWM pulse width modulator which will eventually generate pulse width modulated signals. I also need a latch and a shift register. Shift register will convert parallel signals into serial signals. So to do this project, I have two solutions. In one solution, I have to purchase all of these separately and build an entire circuit which will be very big. If you have the idea, you can guess that the circuit will be very big and the connections will be messy. So what I'll do is I'll go for the second solution, which is to use one particular IC which have all these integrated. And that IC is a microcontroller. Yes, microcontroller has built-in MOSFET, latch, PWM, ADC, counter, shift register, timer, oscillator, all of these circuits built in. And microcontroller can replace all of these ICs and it will save a significant cost. And circuit size will be very small. So what is this microcontroller? A microcontroller is a tiny programmable chip with real-time computing capabilities. By real-time, I mean that the microcontroller follows the same real-time clock which we follow. It has built-in RAM, ROM, that means memory, and it has general purpose input and output. It has timer, counter, signal generation units. It has built-in interrupt sources, universal asynchronous receiver transmitter, which you don't know, but I'll explain it later on. Overall, it has everything. That's why we can call it a microcomputer. So you can say that microcontroller is a tiny microcomputer which is programmable and which can handle real-time computing functions. That will be the perfect definition for a microcontroller. So whenever I went to colleges and universities, I have faced this question that what is the difference between microprocessor and microcontroller? Because in college syllabus and university syllabus, they teach microprocessor, not much about microcontroller. So what is the difference between microprocessor and microcontroller? Let me tell you this. The main difference between a microprocessor and a microcontroller is their use. Microprocessor is used for general purpose, whereas microcontroller is used for a specific purpose. I am giving you one example. If you have seen the computer cabinet, then you may have seen how motherboard is mounted and how we connect SMPS. So now I am asking you a question that if I have a cabinet where there is a motherboard and a processor mounted on it and a SMPS, then will that computer run? The straight answer is no. We need memory. So if I attach RAM, now will that computer run? No. I need operating system to be stored somewhere. For that I need hard disk drive. If I include hard disk drive, then only the computer will run. And the OS should be inside that hard disk drive. That means the processor has nothing. We have to attach externally the memories. We have to attach interfacing circuits like the motherboard has. We have to attach externally the power supply and other circuits. Then only the processor will run. Then why we are using the processor, or you can say why we need that processor and what the processor is doing actually. The processor is actually supervising all the other circuits. It has no capabilities, but you can say that the processor is a supervisor. Suppose I want to make my computer a home theater unit, then what I need to do? I need to purchase a sound card. Then the processor can handle the sound card and it can supervise the sound card to generate different sounds. If I want to make my computer a game station, then what I need to do is I need to purchase a graphics card. Then the processor will supervise the graphics card to generate different graphics. So I can make my computer different things like game station, home theater unit, video game unit, like that. There are many applications. So processor is basically used for general purpose because it's a supervisor. But microcontroller is the skilled labor. So what this graphics card is doing, it is used for a specific purpose. Graphics card is used to generate graphics. Then what is the purpose of a sound card? Sound card is used to generate the sound. So these are the skilled labors. These are made of microcontroller. So microcontroller is used for a specific purpose and microprocessor is used for a general purpose. Apart from it, it has many differences, like a microprocessor has only CPU, but in case of microcontroller, it has CPU with memory, input, output, timers, etc. The cost for a microprocessor is very high, whereas for microcontroller, it is of very low cost. Microprocessor is used in big environments where cost is not a concern. But microcontroller is used in small environments, sometimes standalone units, where cost is a significant thing to be concerned. Now, I have told you the difference between microprocessor and microcontroller. Let me tell you where we use microcontroller. Microcontrollers are widely used in many specific devices and many such solutions like calculator, digital camera, digital set-top box, 2 ATM machines. According to capacity and capability, microcontrollers can be classified. So there are many microcontrollers available in the market. For an example, in 8-bit microcontrollers, we have very popular units like 8051, PIC controllers, AVR controllers. In 16-bit, we have PIC24F, mixed signal processors by Texas Instruments, MSP 430. These are the example of 16-bit controllers. And in 32-bit, we have ARM controllers. So these are the few classifications of microcontroller. Now you may have a question that I have told you about microcontrollers. If microcontrollers are used everywhere, then what is the use of microprocessor? This is a valid question. Let me tell you that microprocessor is used in PLC based automation. Large ship, you have seen cruises, large ship control systems, there they use microprocessor, where a large number of input outputs are required. In military applications, automotive, like in car dashboards, they use microprocessor. So where cost is not a concern, they use microprocessor, and where a large number of input outputs are required, there microprocessor is used. Now, I have told you that microcontroller is programmable. So how we can program a microcontroller? That is a separate topic. That is microcontroller programming. Now I can tell you about how we program a microcontroller. So normally, to write the programs of a microcontroller, we need a compiler first. So compiler is given by the manufacturer itself. Suppose if I am purchasing a PIC microcontroller, then the manufacturer of PIC microcontroller is Microchip. So compiler will be given by them, and it is available on their website. But the difficult part is to choose the programming hardware. So in some cases, the manufacturer used to supply the programming hardware, but the programmers were costly back then. Like I'm talking about 15 years ago, the programmers were very costly, and we had a long evolution phases. Let me tell you that how the evolution happened. So if I tell you about world before Arduino, let me take you back to 15 years. Like I'm talking about the evolutions 15 years ago when I learned the programming. Then the first method was to use an external programmer and a separate development board. In external programmer, we put the chip on top of it, then we program the microcontroller. Then we had a separate development board where we put the microcontroller, and there are the interfacing circuits like LED, LCD and all, and then we check our programming, whether our programming is correct or not. This was old. Then evolution happened and we got one external programmer like that is known as in-system programming, ISP. That hardware is still available. Through ISP, the process of putting the microcontroller on top of the external programming and putting it back to the development board, this process was removed by in-system programmer. So what is the use of in-system programmer? Through in-system programmer, if I have a development board where there is a specific connector is there, then we can put the in-system programmer on the connector and we can program the IC directly, and we can test the program on the development board. So no need to putting off the IC and putting it back on the development board. So that process is completely removed by the in-system programming. Then evolution happened, and another method came, that is a bootloader. Bootloader is used to program the microcontroller serially. So using serial communication, if the bootloader is loaded into the microcontroller, then we can program that chip using serial communication. So for serial communication, we used a cable called RS232, that is a DB9 cable, and that cable was responsible for serial communication. So that particular technology got replaced by USB, and now the era of universal serial bus began, and that USB era is still there, and we can still program the microcontroller using bootloader. So Arduino uses just that. The chip inside an Arduino board is loaded with the bootloader so that we can program it serially. How? Using USB. So the evolution happened, and Massimo Banzi and the team came with a super development board. I can say super development board, that is Arduino. So after Arduino came into the picture, some terminology changed and the process is also changed. Now we can program through USB. Now we can think of that. Previously, like 15 years ago when I learned the programming, we used to say that we want to burn the program, we want to burn the hex file. Now the burning process becomes upload. Now we can say I am uploading the program inside the microcontroller, and programming becomes very easy. Load and test in a single board. Like if you have the Arduino board, the main USP of the Arduino board is the chip, and then you can easily test it on a single board. User-friendly free software. The Arduino software is free, available in internet. You can easily download that and write programs. Easy to write codes and easily understandable codes. The terminology is like the basic, or you can say if you just literally convert the meaning, you'll understand the codes. And another USP of Arduino is we can build many projects in a single day, because there are a lot of tutorials out there in internet. We can easily browse through tutorials and can build many projects in a single day, and easy to build prototypes. That's why sometimes Arduino is referred as rapid prototyping platform. Now, if I talk about the prototyping platform, then let me tell you how Arduino helping us as a prototyping platform. Why I'm calling it a platform instead of a hardware or development board? Because the Arduino organization provides the software, the hardware, and the entire library's architecture. That's why it is called a platform. The hardware is compatible with the software. Without the software, you still can program that microcontroller, but if you use that hardware with that particular software, then it becomes a platform. That's why Arduino is called a prototyping platform. The benefits of Arduino is the hardware is very low cost. There is this free software, we can say it IDE, integrated development environment. This is a free software to write programs. No external programmers required. You don't need to purchase a separate ISP programmer to program Arduino boards. So no external programmers are required. Tons of built-in libraries and external libraries to support the coding environment is there. So if you need any kind of support to interface some other circuits, the tutorial is available in Arduino website. There are built-in tools like serial monitor, serial plotter. You can plot graphs, you can plot charts, you can test data serially. That is very useful for debugging and testing purpose. So those built-in tools is available with Arduino IDE. And there is a separate projects and knowledge base available for learning. Like if you visit create.arduino.cc, you will see there are a lot of projects. You can learn through them, and there is a knowledge base in Arduino website. You can visit that. I'll tell you where you can find the knowledge base, and you can browse through that knowledge base. There are functions, there are libraries, many tutorials are there. You can learn it easily. So that is about microcontrollers and Arduino. In the next lesson, what I'll do is I'll tell you about open source hardware basics. What is an open source hardware and how they have designed and they have planned the Arduino hardware. There are different Arduino boards, and as our target board is Arduino Uno, so I'll tell you about the Arduino Uno hardware fundamentals. Then I'll also tell you where and how to buy Arduino boards. So see you in the next lesson.